Hi everyone, so I'm sorry I'm not there today, but today I wanted to go over the last piece of our transformations, which are horizontal scale changes and horizontal reflections. So first we're going to look at horizontal scale changes, and what we've been working on is when you have a vertical scale change when there's a value on the outside of the function, but let's think about what happens when there's a value on the inside of the function. So here we have our function, which is the square function, the quadratic function. And so here you can see I've got a 2x within the function. So it means that once I put the x in, I'm going to change the x by multiplying it by 2. So all of my x's are going to be changed by 2. And here, all of my x's are going to be changed by a half. So let's see what happens when we do that. So if I graph it, we can see it appears to get narrower. And then if we look at 1/2, it does appear to get wider, except the scale change is on the inside of the function. So we actually call it a horizontal change. So what you should have seen is when that constant, if things are in the form f at c of x, it's the x values that are being directly affected, and the scale change will result in a horizontal stretch or shrink. Now, it's going to look really close to a vertical stretch because a horizontal shrink, in most cases, will have a vertical stretch. So, in this case, when your c is greater than 1, it's going to be a horizontal shrink. Now, if we think about how, if I gave you like y equals x minus 2 squared, when we set our shift, we said this was going to the right 2 because it was going in the opposite direction. I want you to think about when you have a multiplier or a constant being multiplied inside the function, it's going to actually be, you're going to be dealing with a reciprocal when we write our rule, okay? So if c is greater than 1, horizontal shrink. If c is between 1 and 0, it's going to be a horizontal stretch. Why is it when I put the constant inside the function, it changes x? Well, because the function is the square and it doesn't happen until you actually apply the parentheses using proper order of operations. All right, so here are our examples. We've got state whether it be a horizontal stretch or shrink. And remember, it's the opposite of what we would think it is. So here we've got this square root of 3x, the 3's inside. This would be a horizontal shrink. Okay, so again, it's going to kind of feel like the opposite. Y equals 1/4 x. My c value is between 0 and 1. That's going to be a horizontal stretch. Y equals f of 2x. Again, it's on the inside. It's a value greater than 1. It's going to be a horizontal shrink. And here we have 0.5. Could write it like that. That would be a horizontal stretch. Okay, now let's get used to writing our rules for these. So if it's in this form, what you're going to do to the x values is actually going to be multiplying by the reciprocal of c. So you're going to be doing instead of doing like the opposite sign, you're going to be doing the reciprocal. So in this first example, my rule would be 1/3 x comma y. In the second example, my rule would be 4x comma y. All right, I want you to try now. Okay, so you can see here that hopefully you understand that what you're basically doing is you're changing your x values like we said, but you're changing it using the reciprocal of the number. All right, now this is going to all start to get really tricky because now this last piece I want to throw into it is a horizontal reflection. Okay, so as a reminder, a vertical reflection, so over the x-axis, would be something like this. Okay, now let's look at how this might change, or actually let me use a different function. Let me use this function, y equals square root of x. Okay, so I'm going to go back to Desmos because I really want you to see what's happening. So we have y equals square root of x, and then when I put y equals negative square root of x, we reflected it over the x-axis. Now let's see what happens when I put the negative on the inside of the function. Remember, we said when we put something on the inside of the function, we're changing the x's. So we're making all of our x values, so all the x values here on the right, we're making them their opposite, so they're going on the left. Okay, so when we have this is going to be a reflection over the x-axis. When we have it like this, it's going to be a reflection over the y-axis. All right, well, let's see if we can put all of this together. So here it says for each function, write the parent, the rule, and then graph the function. So here we've got 1/3 x plus 4, my parent's y equals the absolute value of x. My scale change is this is going to be a horizontal, I can't spell today, horizontal stretch of 3. My rule, inside changes x, so 3x, y plus 4. Okay, so to graph this, not too bad. Let me go ahead and put these in now. I know that I'm horizontally stretching this graph and I'm moving it up 4. So I'm going to take my parent graph. Let me make some room here. X, y. 2, negative 1, 0, 1, 2, 2, 1, 0, 1, 2. Here's my parent graph. My rule was 3xy plus 4. So I'm going to multiply all of my x's by 3. And I'm going to add 4 to all of my y's. Okay, now I've got 6 on here, so I'm actually just going to leave it because I can. So let me give myself some room here. So negative 6, 1, 3, 4, 5. So 6, negative 6, 6. Right about there. Negative 3, 1, 2, 3, 5, 0, 4, 3, 5, 6, 6. So here we have that horizontal stretch of 3, which means I'm pulling it closer to the y-axis and moving it up 4. Okay, I'm going to actually change b for you. Okay, so I want you to cross this out. I want you to do h of x equals the square root of negative 2x plus 4. Okay, so go ahead and try that and press pause, and I will have the answer up for you. Okay, so you're checking your answer. Horizontal shrink of a half, rule of negative 1/2 xy plus 4, and there's my applied rule. All right, so I'd like you to try the domain and range for both, and you can check your answers on the website. All right, guys, that's it. Have a great day. I'm sorry I'm not there today, and I'm really tired, so sorry for it being so boring. Have a good night.